Thanks very much for agreeing to let me take over for my 20 minutes on a Saturday afternoon. So my name's Jamie. I work for Jumping Rivers. I'm one of the original members of Jumping Rivers, so I've been there from the very beginning, which makes it sound like a long time ago, and it definitely feels like a long time ago, but actually it was only 3 years. I also have to start this talk with maybe an apology is an appropriate word. So this says real-time shiny, because that's what I submitted for my abstract. So when Colin suggested to me that I might want to give a talk at Satar Day, I thought, oh, that's a great idea. Yeah, I'm happy to do that, sure. And then I forgot that we'd even had that conversation, and he sent me another email later on in time saying, kind of need your abstract like yesterday. So I sort of put one together thinking I have a really good idea what I'll do for that. And it turned out I was wrong, and I didn't really have a good idea at all. So this talk very much became a talk-driven development exercise. I'd kind of committed to doing something, and on Tuesday I still had nothing, so I had to sort of make something. So really this talk now is more my experimentation into trying to solve some of the problems associated with real-time shiny applications, if you like. In particular, I actually had a particular goal in mind that I wanted to achieve. I think everybody here is probably familiar with Shiny, right? The logo and Show Me Shiny and things like that. We've got this idea that Shiny is this web application development tool for R that takes away all of the pain of writing HTML and JavaScript, well, at least allegedly. But I had a particular piece of motivation, which was Facebook. Now, I hate Facebook. I think it's a terrible website. My wife wastes all of her time talking to friends on Facebook. I think it's ridiculous, but they do some cool things when it comes to programming and other stuff. I've also gone for the very risky talk strategy of not actually really having any words or text on my slides. I just have bits of code and other things that I'm going to try, and hopefully more successfully than the previous talk, without wanting to be rude, just the whole internet connection idea. Hopefully mine will work. Fingers crossed. So Facebook do occasionally some useful things.
Jamie, can you up the font size?
On the bash terminal, or... I'm literally...
Maybe if you right-click on the tool, on the window...
In essence, the terminal doesn't actually care. I'm just going to run stuff and then show stuff afterwards, right? So... if you really care what I'm typing here, I'm typing the word wisdom. It's the name of a Python package. I know we've not been mentioning the P word today. That's why I'm keeping it small. And now things run slowly, so I feel like I'm falling into your trap. Thank you. So, wisdom is, I know we've been avoiding the P word, but it's a really cool application made by Facebook, and it feels similar in theory to Shiny, and somewhere in here we should hopefully have, well, literally nothing by the looks of it. Where is Jumping Rivers Git? No, come on. I'm definitely doing your trap here. Choose working directory, yeah, this one I'll do. So we've got example for wisdom. So it kind of feels similar in essence to what Shiny does. It's a web server that allows me to have interactive graphics, but it differs to Shiny in the way it works. Instead of building the entire user interface with all of my data that powers that particular application ahead of time and then viewing it, I sort of launch an empty user interface and I send stuff to it. Right? So I can have multiple Python sessions running in all sorts of different places. I'm running complicated machine learning routines that are getting predictions here of random numbers, and I want to see what's going on, and so I just send them to my server. Right? So I might have loads of different parallel jobs running for different tasks, for different data sets, for different machine learning models, whatever, and I can sort of monitor them all in one place. And Shiny doesn't really fit this same pattern. So that was kind of what I wanted to make when I proposed this abstract without really thinking about what I was going to talk about. So I guess sort of traditionally in Shiny apps, data tends to be fairly static. right? You have a CSV, you have a database connection, maybe you're retrieving data from some API, you know, you're polling Twitter API or something like that to see what Donald Trump's been talking about. And to view updates in your Shiny app, well, you might, in the most trivial sort of fix for this, add data to the database. So maybe I'm going to be a little too risky here with my demos because I have a number of them. So example, refresh. So if I run this, I should start a Shiny app which will view some data that lives in my database or my file. And when it's done thinking about how it wants to go about doing that, we can add new data to my... Are you okay?
Yep.
Good.
Hiccups. You just have to ignore them.
So we can set up a connection to my database and to view the updates to my Shiny app. If I view what's currently there and new data gets added by this very complicated insert statement, nothing actually changes about my application, right? There's no real-time update to what I'm viewing. If I want to see what's been added, I have to come back to the application later, refresh, and now my new point has been added on to the end. And that's sort of the most naive way in which I can see data updates. Very much not real-time. So add data and refresh the page. Now, of course, this has lots of issues because if I'm actually querying a database, I might be waiting forever just for this page refresh anyway. Right? What can we do to try and take away at least the manual element? I might use something like reactive timer. Maybe I won't run every single demo I wrote here, just conscious that Robin will want to talk at some point too. But I'll show you some code for my same app that will take care of this refreshing statement. And essentially what will happen in this particular application is every second... Am I looking at the... Oh no, apologies. Every second my application uses something like a reactive timer to say, okay, every second go and run this query again and then redraw my graph, right? So at least now I get some auto-refreshing behavior, but this is kind of old-fashioned. This is a drink, by the way, called old-fashioned, if you're not familiar. Essentially, what are the problems with this repeated polling type idea? Well, how often should I make a request? Right? I'm querying a server which might have a lot of data in it, and so each individual query and result set is going to take a long time. I might be querying an API that is slow, expensive, who knows? If I don't make a request often enough, I get really slow updates in my dashboard. Right? I say every 10 seconds, and somehow that really doesn't feel real time. I say every half a second, well, that might be too much. The Shiny server is spending loads of resources making all of these requests all the time. And of course, if the backend API has a rate limit, I've now got to make sure I'm not going over that rate limit. Right? So there's all sorts of horrible problems with this polling type approach to live updates to the data in my application. If this is an API that I've not developed, and I'm using somebody else's API, do I have to pay for each request? Because now this is a really big consideration. Right? And if nothing has actually changed, I'm completely wasting my time anyway. I'm now paying to make a request to get back the exact same response that I got last time. And not only did I do that once, I'm doing this every single second. It just turns out that right now, nothing's changed for an hour. So I've just paid for an hour's worth of hits to an API for nothing. And so this polling architecture is... well, the other thing that really bugs me about polling is it's not quite real time. It's spoofed real time, right? It's every second or everything that I've picked some regular interval in order to update my data. So that really bugs me because people call it real time, but it's not, right? It's cheating. So given this sort of paradigm that I've set up for myself, what do I want? I want some way that I can send data directly to my Shiny app. And I also don't have to worry about auto-refreshing via some reactive timer or something like that. And one of the things about Shiny that makes this difficult is that Shiny web servers respond to GET requests, right? You can receive resources from your Shiny server, you can see what the dashboard looks like, but it wasn't designed, I may be corrected by our studio employees here, but as far as I'm aware, it wasn't designed to handle other types of requests, like adding post endpoints, something that would allow me to send data directly to that application. I know there has been talk about adding sort of an API structure to Shiny, but as far as I'm aware, right now that doesn't exist. There is actually a Hacky solution that you can do to force Shiny to accept a post request. So this is sort of a shortened version of what this might look like. So the session argument of a Shiny server function has this registered data object component, which essentially allows me to multiplex a particular request query string and then check whether somebody had added the annotation that it was a post request. And so I sort of deal with it in this horrible roundabout way. There is a Stack Overflow link here if you want to sort of read the full discussion on what's going on here. But this definitely hacky solution doesn't feel very suitable because when I register this data object, I get a unique ID for what this endpoint looks like. But I haven't picked it, so it's random. And now I need to communicate that somewhere else somehow. So I need to retrieve this, and there are ways I could do this. I can send a message through the browser, but it's becoming problematic, right? Because now every server session has a unique endpoint to send things to, and that's potentially problematic in its own right. So I wanted to be completely transparent. In theory, you can force Shiny to do a post request, but I don't think it's very good. Having said that, I don't think my approach over the next few slides is actually any less hacky than this. But I've got around this problem of communicating endpoints through a browser, and I feel like I've at least got around this auto-refreshing, so I'm semi-happy that I've done something that I set out to do. The other problem is I really don't know anything about networking. I mean, I like R, I like Python, I write both of those things fairly often, but I don't know how servers work and how web communication actually works. Whenever I need to know anything, I just ring Seb, and he tells me the small piece of information that I forget 5 minutes later. But maybe my solution looks a little bit less hacky than this registered data object solution. So the route that I thought I would try and take to solve this problem uses Websockets. Essentially, Websockets are a communication protocol that we can use over the web. It gives me a persistent connection between a client, so a browser, and a server that's running, say, my R application, and it provides an avenue for two-way communication. I can send messages, I can receive messages. Essentially, all of the internal stuff of Shiny uses WebSockets for communicating between JavaScript, R, the client, and the server. And in R, there are a few packages around for creating, manipulating, doing things with WebSockets. So there's HTTP-UV, which I believe Shiny is built from, and then there's WebSocket as well that we could play around with. So on Tuesday, when I suddenly remembered I actually had to build this talk and try and build something that you could see, I made version 0.1 of my version of Shiny's Wisdom Facebook product. So I shall hopefully run that for you now. So we have example 0.1. We have an app. I'm going to run the app from the terminal rather than from my Shiny, from my RStudio session, just so that I can run other code for you. So version 0.1, run my app, and we'll navigate to the browser so we can see what it's doing. Right? So much like the Wisdom product by Facebook, I start with an empty user interface. I then have a module of R code that I can create, which essentially gives me what the Wisdom object from the Python library would give me. And essentially I've got a function closure here that sets up a connection to a WebSocket that my Shiny app is listening to. Right, so my Shiny app also launches a socket server waiting for communications. Whenever it receives a message over this WebSocket, it's going to update some reactive value on my Shiny session. Right? Reactive value, I can propagate some event that updates the user interface. So I register my sender, I draw a graph, library ggplot2. I'm too lazy to actually draw my own graph, so I'm going to use a fantastic package that I discovered the other week called shiny.collection for generating random graphs, he says. There we have a random graph object, G. You can see it here in my RStudio session. And then what I'm going to do is create now my sender object based on the function closure above, which gives me the connection to my WebSocket. And now I should be able to say, okay, my sender $send this graph object. There's a load of default arguments here for how this is going to get labeled. But now in my browser, I have a new tab's appeared. And in this new tab, I have a graph. And so I've successfully managed to transmit this graphical information from one R session running somewhere to another. And I thought, awesome. Right? This is what I had in my head when I wrote the abstract. Thought, great, I'll just show that, it'll be fine. Turns out when I built it, this kind of works, except it doesn't. So, of course, if I show it to you like this, it looks like it works. Right? And I can add new tabs and everything. So, you know, I add the additional argument here, tab equals new tab, and I go back to my web browser, I've got a new tab, it's also got a graph in. Feels like success, but of course I completely cherry-picked the example, because if I actually deployed this on a server, and 2 people tried to view my app, damn. Oh, 5 minutes as well, that's a real damn. Yeah. So, now 2 people are seeing different things on the same app, and actually it gets worse than this, because now if I send a new graph, let's add a new tab, where does it go? Well, this one made it to the newest viewer, but not the oldest viewer. And so it kind of did work, but really kind of didn't, because I can't actually share graphs across different Shiny sessions now. And there's no data persistence either. You know, if I close the browser and reopen it, everything's gone. And that felt like, whilst it looked like it worked in the first place, it's kind of useless. That doesn't actually solve anybody's problem for anything. So I spent Tuesday evening panicking about how I was actually going to present something that looked useful. So I decided I had to have a rethink of things. This is version 0.7 because it's definitely not ready for actual use yet. There's also a terrible pun coming in here. I had to rethink things by using Rethink database. That's as good as jokes get in talks like this. So I was looking around for a solution, and I came across Rethink DB, which has this particular quote on their main front web page. When your app pulls for data, it becomes slow, unscalable, cumbersome to maintain. Rethink DB is the open source scalable database that makes building real-time apps dramatically easier. Well, that sounds like exactly what I want to do. This seems like the perfect solution to my problem. Of course, I didn't know anything about it, so I had to go and learn. There are a couple of R packages that exist for interacting with a Rethink database. I realise I'm now speaking in increased speed, but that's to try and fit in the 5 minutes that were left. So there's Rethinker and shiny.collections, which there was a talk on at I think it was the RStudio conference actually, 2 years ago, which deal with Rethink database. So I had a look at some of their code and some of their examples. And the shiny.collection package in particular has an example of sharing data between 2 Shiny sessions, which was one of my problems with version 0.1. The last actual library update was in 2017, and it still didn't quite do what I want, because the way in which it worked meant that I couldn't insert data into this database from a non-reactive context using the structure of this particular R package. So what's the answer if you find an R package that kind of does what you want but not quite? Well, you fork it on GitHub, you steal it, you break it, and then you rewrite it in your own image. So that's what we did. So the installation of shiny.collections on my laptop is different to everybody else's installation of shiny.collections because I didn't even bother renaming the forked repository. Essentially what I did was take away all of the stuff that didn't have to have a reactive structure and left only the things that needed to be reactive as reactive. And so that leads me to example version 0.7. Yeah, don't save, don't care. 2 minutes, yeah. Semi-care about that one. I do care. So my Rethink database, if I kill my shiny app, oops, cd, stocks, apologies. So the reason I'm spending a little time running everything here is because I now have to run a database and everything as well. So I should get another URL which starts in the same fashion as the previous one. Does anyone see a... There we go. So I get a URL like before, which starts in the empty sort of structure. I have my sender code, if you like, that initiates the test socket, and then we can do the same as before. I'll create a plot. Do I still have a G lying around? Yes. So create my connection to the WebSocket, and send my graph. And that's because my sender is a closure, not an actual function. Have a graph with some stress. But now, because I'm using a database which has a sort of a connection that's shared between the two sessions, I can have as many people viewing this one application as I like, and they all see exactly the same state. So I've got around the problem of sharing state between two things. I've also got around the problem now of if I have a new tab sent, it gets picked up by both, and the actual viewing state of each user is independent. Right? So if somebody navigates to default, it doesn't ruin Joe blogs who's still looking at tab new. And so now I've got a structure that allows me to run R code on multiple machines and sending all of my output diagnostic graphics to one place. So anybody, some manager, can see what all the different teams are doing in terms of their graphics output without having to navigate a ton of applications. So this was the point where I was semi-happy. I can send any type of data. I chose graphs here because they're slightly more complex objects than sending single numbers. If I can send a graph, I can send pretty much any R object that I like across this connection. I can share this across multiple sessions. Awesome. I now have persistence as well. If I close this, I'm going to copy the URL so that I don't forget it, and then come back. I don't know why Twitter docs have just opened. My state is still there, so I've still got the state of my particular application. So I'm kind of happy in terms of meeting the goal of what I set out to do, which was the wisdom thing. Right? I have something now that kind of looks like that. There are some issues with this, if I'm being completely honest. So I seem to have to run the socket server and the shiny server in the same R environment. I don't know if I'm yet quite smart enough to figure out why that's true. It would be a lot better to have these two things isolated from each other. If I separate the socket server from the shiny server, it still receives everything and they all get put into the database, but somehow the auto update step fails to work anymore. And I really have no idea why that happens. I really want to solve this problem because it means I can start to connect it up with other R web connected services like Plumber that we had a talk on, and have dedicated endpoints to send separate things to in my application. So what might I do next with this is try to use Plumber to create those endpoints. I can say, okay, I want to send graphs via one endpoint. I might want to send different types of objects to other endpoints. And then I guess what I'd want to do is sort of start to package this up so that I can have one single structure that allows me to send essentially anything to a single point of contact from many. So that's what I would do next. I did decide last night and I will finish and sit down in just a second. I apologize. I felt a bit guilty that my talk was called Real-Time Shiny, and then there was not a single actual example of anything running in real time other than me sending graphs and then being received. So last night, whilst I was, digesting pizza, I decided I actually had to have something that looked real time. So if you'll bear with me for one final example. In my final example, I have an example of an API. So this API was written in the horrible language Python that we're not mentioning today. The only reason for that is I could more quickly think of what I wanted to write in order to provide that. So we can start my Python API, and then in my RStudio session I have some R code that isn't really R or shiny code, because of course it's just JavaScript being injected into the particular application, that allows me to listen directly to a post endpoint like this. So if I actually run that application, and this is definitely cheating for an R conference, because it's not really R, it's JavaScript. But I now actually have something that is at least a real-time demo. As things are being emitted from the server, they're being picked up in a graph as well. And so I'd quite like to turn this into some sort of regularized structure as R functions as well. Anyway, thank you. Sorry for running over.